Next slide, please. Then please join us to welcome Harrie Schoots, a globally recognized expert in textile wet processing with more than 25 years of expertise improving the yarns, fabric, and garment performance across dozens of countries and hundreds of mills. He is the primary inventor on over a dozen patents and served as the president of AATCC from 2020 to 2021. So today, Harrie will discuss how the emerging technologies like the tactile sensation analyzer and the digital haptic libraries are enabling the textile industry to objectively measure and digitize the fabric handfeel and comfort. Using real case studies, he will illustrate how quantifying these properties can improve the material comparison, product development, and supplier brand communication, moving the industry towards data-driven decisions, similar to how the color measurement has transformed the textile standards. Then, hey, Harrie, please kindly take over when you are ready.
Sure. Thank you. I appreciate being here. I welcome everyone. I think most of us are domestic here in the US, but I welcome everyone who might have come in globally as well. I do have a background in textile chemistry. I graduated from NC State College of Textiles the year after NAFTA was signed. So I am what I call the youngest of the old people. I have been around the world a few times back when they still had budgets for that kind of thing. And I was just blessed to experience many, many technologies and being able to commercialize them. And so it turned out to be a great experience. During the shutdown, I ended up turning to consultancy, and I've survived so far. But it also gives me the chance to, being a consultant, gives me the chance to represent interesting technologies, also ones that I search out. And like this one today, I actually find this to be fascinating and a useful thing to do. And so I look forward to teaching about it. So we'll start with the next slide. The discussion today is about haptics, which is the fancy word for hand feel. I think everyone has a version of that name, you know, how something feels when you touch it. But the bottom line is when you look at how a consumer decides what they do in a store, I think it's something like 60 cents on the dollar represents what it looks like. And so color. This is the whole business of merchandising, has to do with color. You know, how do you set up windows in the store? And now, of course, online, how do you attract people's attention? It's with color imagery. And so color went through the paces of digitization. And I was part of the people that used to buy spectrophotometers for color, where, you know, you would be mocked for trying. And it was, you know, very much an impossible thing to do. And so from that, in that vein, I think we should, in that context, I'm bringing this forward. So people have wanted to connect digital hand to a number, for instance, something measurable, for a long time. This is not a new concept, but I believe that this particular instrument you see on the screen here today is a very good option, if not the best in the world, because it's already the standard machine for the paper, tissue, nonwoven business, and is used every day to specify, especially toilet paper has adopted this around the world. And the second thing a consumer does after they see it, if we can guess, obviously in this topic, it's then you touch it, right? You enter a store and you put your hand on it. And then there's a process in which people start touching. AATCC actually has a process. I forget what we call it, like a EP or some kind of advice on how to touch fabric, you know, how you condition it, whether your hands are dry or not, that kind of thing. And so we've done the best we can without digitizing on trying to make, you know, how do we talk about hand? So about 30 cents, 25 cents on the dollar is what happens after they touch your product. And then when you're in that uh, store, the third, some people will argue what the third thing is. Anyone who owns a brand would say, well, the brand is already the decision. You wouldn't walk in even if you like the color. But that can be argued later. The third thing is, you look at the label, you look at the price. So I think pricing is a very high number. But the bottom line, the second decision making, in order of how somebody makes a decision that they buy something, whether it comes to them in a box, online, via online purchase, or in a store, is to touch. And so this is a very big deal. This thought process. It's not just the production side of this, and we're going to talk about some of the value in the production side, like quality control, assurance, those type of things. But also, how do you know if a consumer is going to like something? So if you see here, you'll see the TSA stands for a tactile sensation analyzer. The VHL actually stands for a virtual haptics library. So most of the technologies out there today kind of have to combine both the instrument itself and also where does all this data go. And so the hope is that you would have a cloud-based data system that can be searched. So if you're selling fabrics, you can then offer a searchable, if you want the softest knit product we have, you'd be able to search it now. If you want to search many people's fabrics for the softest, you could be able to do something like that. So, and my little dream is that little picture you see in the bottom there. We'll see that on the last slide. And that's to have like the CIE LAB color three-dimensional space. We should be able to create that with hand as well. So reminder, just raise your hand with one of these icons here if you have questions. We have plenty of time for questions. I don't have a ton of slides here. This is going to be more about the parameters and the language of this application than it is about the instrument and how it works, that kind of thing. So that we do have built-in time. So here's the problem. Highly subjective parameter. That is a very fancy way of saying, it depends. Is it soft? Well, it depends. It depends on who's touching it. And so that's the basis of this type of technology, is that we have to get over it depends. Just like everyone has color opinions. We have the same thing, maybe worse with haptics. There's more involved with haptics than there is with the eye, even though there's 190 million rods and cones. So I'm not sure if it's good to say, maybe they're the same. But the bottom line is, when it comes to hand, you have, I just got a big echo. So if somebody mutes, that would be great. The bottom line is, these instruments have to be designed in a way that overcomes the differences, and that has to be independent of each person's personal opinion on how something feels. And I think the answer to that has been that there's a lot more variables. We're going to call them parameters. So the parameters to hand feel are not just the three that you have with color, L, A, B, L star, A star, B star, for those of us who are experts. You see here in this little circle, you've got quite a few. And they have opposite words too, which the next slide I'm going to show you. But it's a whole new world when you come into this space and see that there's a lot of new language. And just like we had to overcome the designers who wanted to tell us to make the color warmer, which I think anyone here over 50 has actually tried to make things warmer looking, softer looking even. When some people say, I want it to be softer, and you say, how soft? I want it to be 1.5 cents softer. That's an actual quote. That actually happened in my life. So let's go down this journey here. We'll go to the next slide. So here's kind of a busy slide. I hope you're not looking at this on a phone, but it's what I'm trying to do here is, you have the third column there says parameters. Those are I think in order of importance, the parameters that are measured by the TSA instrument. And I put their opposites next to them. So you see surface softness, and then the opposite is hardness, okay? Now, one thing I want to make sure everyone knows, this is for fabric only. This cannot be done on yarn by itself, but the yarns within the fabric obviously make a big difference in the ultimate results. But if we go back to the basics, I wanted to know, what does each one of these 8 parameters represent when a consumer is touching fabric? And I've tried to do that over on the left here. And the scientists from MTech, which is based in Leipzig, Germany, who've been working and making this machine for the paper industry for over 25 years, got me some pictures as well. And I love that second column there, kind of gives you an idea. For instance, one of the most remarkable tests and useful is called crumpability. So the first thing one does when they touch fabric is they touch one side with one finger. The second thing, you'll grab both sides and you'll move your fingers. And one of the things you do eventually is you grab the fabric and you crumple it in your hand. The measurement on that one is the resistance the fabric gives you to crumpling. And those represent, and all the other parameters you see here represent some form of either wearing or touching. And I thought this would be a nice thing to show. Now, you see a column there, it says AATCC test method. So for those first 5 parameters, they will be mentioned in a test method that should eventually publish through AATCC. I wrote the date here, is that the ballot's going to go out to the RA89, which is the Hand Evaluation Committee, on February 25th of this year. There is a Chinese national standard that is using this machine with these parameters and these testing protocols that is going to likely publish this year. And that will be for textiles. And then on the column after that, there are some existing test methods that are that this is written into for the tissue paper industry, the toilet paper industry, that you see a tappy one there. There is somebody who just created a test method in China for underwear using this. So that already exists today. And then certain testing parameters, they align with ASTM test methods already. For instance, the crumple resistance is related to ASTM stiffness test. And so there's actually a deeper analysis here, but I just wanted to give everyone kind of a taste that this isn't just something that's sneaking up on you brand new, all right? This is something that's really out there, and it's our challenge in the industry to find a way to use it, make it valuable to each one of our jobs. For those of us that are really nerdy, on the right side, I have the units. So in some cases, the parameters don't have units. And I'm going to skip that today. But the bottom line is, in many cases, they have been tested against hand panels, actual people that have run out and done this. And that is something, of course, that can be done by anyone. If you look at the takeaway line at the bottom, when you have an end use, you have to, the goal here, in my opinion, is that everyone wants to know, how soft is it, right? What does it feel like? I want to compare it apples to everything. There's going to be a little bit more difficulty in comparing to everything than color. It will be have an end use related algorithm. So the algorithm that is created for your use, if you're using this machine for intimates, will be different than workwear. Okay, so there'll be small differences, but those differences are worth containing in your work. And so when those end uses are given to the company that makes this instrument, they produce what's called a delta Handfeel number for you. It's between like 0 and 100, where 100 feels, let's say, superior, 0 doesn't. And that when you are a 3 or more difference in that category, then it's noticeable by the consumer. Now, even if you didn't have a full delta comparison, which is very difficult to do, if you can imagine, with all these parameters, including the bottom 2, by the way, which are more thermo-related. You'll see that there's a heat transfer test here that's delta K. and a warm touch. I'll get to the question in 1 second. But if you take away even the thermo ones, there's a lot of parameters here. And you're going to see some data soon in a few slides down that will show you how you have to kind of make a decision on what you're going to use and what you're not. Because if in the end, if you're measuring 50 fabrics and comparing them, it's going to be a large set of data. So again, you can choose individual parameters to specify, or you can try to gather parameters together and compare fabric to fabric. It says the slide is not focused. Okay. We're going to try to get that bigger at the end of the meeting. Any other questions right now? I think there's some hands up.
Yeah, there is a question from WJ. He asks, what is the cost of this unit?
This unit costs a little bit less than a spectrophotometer. That's the way I'm going to share it. Is that good enough? So it costs more than a croc meter, but it costs less than spectrophotometers that have some annual fees for software and things like that. They're a little bit more mature. In this case, it's just one software. There are some additional parts to the machine. For instance, crumpability is an additional part. I'm going to show you some of the mechanisms on a slide and how this thing measures things. There's also the thermal, some of the thermal testing is a different part or attachment, but for the most part, it's in the range of a spectrophotometer. All right. Yeah, Keith's note there is that Handfeel changes based on end use. I think what the algorithm needing to be related to the end use has to do is that people's perception of the Handfeel is different, even if it were a similar fabric. Now, the ratings are still what they are. It's when you try to make an algorithm that does delta H that I'm told that they want to see the end use. That's what I was told. So they have one for paper, for instance, they have one for toilet paper, an algorithm. And so for wovens that are used in bottom weights for uniforms, there'll be an algorithm. Heather, you got a question?
Yeah, can you hear me? Is my
Yeah.
Okay. So my question is, I'm looking at the chart and it says the parameters are thermal insulation and then parameter opposite is thermal conductivity. But I would think that thermal conductivity is not the opposite of insulation. Conductivity just means, is it conductive or is it not? So I would think, I don't know, I just have the terminology is weird.
I think
Because conductivity is like, it's either highly conductive or not conductive.
I like what you're saying. So this is the battle that I'm in right now, is to make sure these words are right. And that's part of actually, I'm going to write this down that you said that. It really just means, so if you know the way it measures, it basically starts heating from one side of the fabric and it waits until the heat reaches the other side. And so this thing can take a long time if it's a very thick layer of fabric, for instance. And that's all it is. So I think the conductivity word means that it transfers through. The heat will move through it. Where insulation means that it won't. It'll resist the transfer of heat. Okay?
Okay.
Okay, so we'll move to the next slide.
Oh, there's another question in the chat.
Okay, go ahead.
Yeah,
does the base fabric affect softness when comparing? How do we factor in this in Handfeel? A number of variables that affect the variable of softness are actually almost all of these things right here that are listed with the red star and smoothness. Softness is affected by an enormous amount of the variables. Twists per inch, the yarn count, the staple length will affect softness. Texturizing, obviously, right? Open end or not, having a softener on it, having been dyed black with 5% dye instead of 0.5% dye for a light shade. These will all affect the softness. And so every fabric has to be measured. There's very little that you can actually transfer over to another. I'm going to show you an example of about 45 base layer fabrics that were all measured and compared to each other on a couple of variables. And then you'll see how much difference you can see between some of these things. What I wanted to show this slide for, and believe me, if you want to get into the depth of how this works, what's the technology behind it and the mechanism, there's a tremendous amount of data. All right, slides, like 80 slides long about just each one of these parameters and how they're measured. The important ones I wanted to say here is that air permeability is part of the measurement and the algorithm of softness. It's part of the smoothness. There's an overlap. Sometimes one thing is done to measure for another. And in this case, air permeability is one of those. And that breathability variable is an important part of the next things that are measured. So very unique here in step 2, the thing I love the most is that they use sound to measure the surface, or to basically wrap around the fibers and all this. The sound measurement is so accurate that it can determine quite a repeatable, detailed, precise measurement of everything from pile to pilling. So if you wash something or ran it through a martindale for 50,000, you could actually measure it through this sound system, and it will tell you how many pills you have based on the size of the pilling and the way the sound bounces off of those things. So there is a friction measurement. So there's a spinning piece of plastic that touches the fabric, and it moves and will receive resistance from the surface. And then there's a stretch and recovery, which presses down a little bit and then comes back, and it measures everything from hysteresis to percent elongation and recovery, those type of things. And it can do it over a great deal of time. So you can leave this thing on all weekend and see if the stretch remains over time. It's pretty cool how much you can do on the side if you were using this with some creativity. There are a lot of test methods or testing that you can do right next to your desk. So if there was any questions about this, we can handle those now. Otherwise, we'll move on to the case study that I have. We got one. VJ?
Yes, just wanted to ask, how much time it takes for step 1 to step 4 to complete? All of them are going together, or it's going one by one?
That's a good question. I left it out of the chart so that we could read the chart, but I have those. It's about 30 seconds, and you get the first 5.
Step 1 to 4, or
yeah.
Okay.
Softness, smoothness, friction, stretch and recovery. It's about a 30-second process. And then generally you would measure 4 of those. You take 4 different. This particular machine uses a 100 centimeter circle of fabric that is consumed when you use it. You have to cut that fabric, you place it inside, you clip a lock on, and then it measures that fabric. And then just to make sure that everything is accurate and that there's no deformation from the test itself, they never test the same piece twice. But you can test both sides, and that way you get to feel the technical face and the technical back.
Makes sense. Thanks.
All right. But it's a very short time, and that's pretty cool. What I was told is the longest test is the thermo test, because it has to heat through on a micro level. It heats through, let's say, a centimeter of fabric or even a couple millimeters of fabric. Can take a very long time.
Wouldn't that damage the sample?
Because no, damage to you and I, no. Damage to the test being able to be accurate if you did it again, yes. So this is a very sensitive testing, if you think about it, right? If you have a sonic curve being created, looking at the bumps on the fibers, that's very accurate, very micro. And so they don't like to use the same piece twice because of that. but it's not like you see anything, right? The fabric still on a macro level looks the same.
Yeah.
Hey, Norma, got a question? Glad to see you here.
Thank you. Can you hear me?
Yep.
You know, what's fascinating about this is I don't believe we in textile measurement have ever considered sound as a unit that, and certainly as it's related to textiles. And I find this very fascinating because it certainly would relate to something like the crumple thing, and you know, some of the other mechanical issues related to, does something sound different when you move your hand across it?
Yes, that would be a macro sound. That's like a
Yeah.
macro sound. You know,
Yeah, yeah.
everyone knows the swishy pants, right?
Oh yeah, yeah.
Swishy pants are another, that's like a bigger issue.
Right.
That's, I think this is such a small and accurate sound that it's basically measuring. So you see a sonic curve, you get that out of every reading, and the sonic curve has two peaks that are valuable. One peak is for softness and the other's for smoothness. And the way it measures softness and well, I should say it this way. The sound is basically, it knows the distance it needs to go and it knows how long it takes for the sound to come back. So it's not just, is there sound on the it's
Right.
using sound as a distance measurement and a roughness measurement, so to speak. So they even have a sound deadening, like a Bose headphone. They have a sound deadening speaker on the instrument so that any outside sounds around will not affect the readings. It's really remarkable, actually.
Fascinating.
Yeah, I love it. That's why I'm here. Okay, so let's go to the next slide. I have a case study, and this is where the audience here will see things that they've never seen before, because this is only a few weeks old, actually, this data. And that's been one of the problems with this world, this whole hand measurement thing, is it's hard to talk about it because we always want to compare things. We want to see, you know, soft compared to what. And so that's what I'm trying to do. I'm trying to translate this to our audience. So the swimwear liner is a very interesting business because, and I didn't know this, but swimwear has two layers in many cases. Like a one-piece swimsuit, women's suit, has an outer layer that you can see and touch when you're wearing it on the outside, but it's a different fabric on the inside, the part that's touching your skin. And you never touch one of the sides of that inner liner. It's, you know, sewn up against this other side. So the one side that's designed to be up against the skin is very important to know. These were all measured dry, by the way. That gives me a chance to tell everyone that this can be done wet as well, because then changes everything, right? We all know what a swimsuit that's stuck to your skin feels different than a dry swimsuit, and that can be done here. But what you're going to see is knit fabrics that are polyester and recycled polyester, nylon and recycled nylon. I think it's mostly nylon 6/6, and they all have some portion of spandex. I don't have a relationship between spandex chart, you know, to the end results for you, but I do have a relationship between smoothness and softness and fiber type. So it's a very interesting case study. I see two hands raised.
So Heather has a question.
Yeah, I had a question about one of the things that it measures is thermal effusivity. So can you use that data to convert it to Qmax? Or
You know,
another?
You can, you know, honestly, you can use, the worst thing I could do is say the wrong thing here, okay? So I'm going to say that first. Second is, you can use these results for a whole lot of stuff. You know, I'm just going to say the thermo world is like the Wild West right now, because I define the Wild West as not exactly a standard yet, right? So we don't have everyone going to the same standard, but a massive demand from the consumer. And so that leads to the Wild West, which is There's all sorts of people who sell yarns that are cool, or phase change materials that will cool at a certain point. And this reading is not the Qmax reading, but it is a very useful temperature change reading. Very accurate as well.
And I had a second thing too. Oh, sorry, go ahead.
No, I was going to say I would use it for many more things than just hand. Knowing now what it does, but I know that, in this real world, we all have to have standards that apply, to the instrument we're using. But it is quite handy, many of these tests.
Yeah. And I just had a statement really. I think it would be amazing to see a study on touch sensitivity for people on the autism spectrum disorder. Autism spectrum disorder spectrum, I guess you'd say. Because a lot of people talk about adaptive clothing and all of this stuff. And actually as a person on the spectrum myself, it's interesting because I can't stand the feel of microfiber and PK polo fabric.
Okay.
But as a part of my job, I have to, of course, feel it and everything. But it would be really interesting to see the differences of, people who love the softness of microfiber versus, just a thing I thought would be really cool to see.
And that's perfect, right? So those are the things I'm starting to find, is that this requires a lot of work. There's a lot that can be unlocked now. And I'm only going to show you one example. It's swimwear liner. And but it's a big deal. These swimwear businesses, they get accepted or not accepted by how it feels. Arbitrary. I mean, it's just it doesn't feel good. So this is obvious for that reason, valuable, but it's also valuable to determine, how much hemp in a cotton blend matters, right? How much do you need to have? Does it make it softer? Is certain degumming better than other degumming? You can figure that out with this. So I look forward to getting a list like that, Heather, but I'll remember that one. Okay, next slide. Now, the left side is not for you to read, so don't panic. I just want to show you that you get a lot of data when you do this. And the list that you see on the left, we'll see that in chart form next, and it'll help. But the bottom line is there were quite a few of these. These were all done in an office setting without, what's it called? Controlled temperature and humidity. Obviously, that's what you would do if you were running this in a lab. But when you run all the fabrics exactly the same, then maybe you're still reasonably close to what these can be. And so that being said, the question is, what do you do with all this data? What are we going to do now? Let's just assume we all had this instrument. What difference does it make? Why? Why would we do this? So I started a list here on the right, and it really depends. So it depends on where you sit in the value chain. Obviously, people who texturize yarn, this is a big deal. Texturizers spend their whole life trying to get 0.008 cents more per kilo because they texturized it longer and they say it's softer. This is a way for them to prove it. And so that's a bit obvious reason. And then there's other ones like this list here I have. Are you comparing fabric constructions? You might have been using a jersey knit for a very long time, but you thought maybe a PK because Heather's not in that market, right? But there's obvious differences between constructions, and a lot of times it's decided by design. That's fine, but sometimes it's decided by cost, price, comfort. How something feels, and that would be a good thing to do. Then you have yarns. I mean, my goodness, how many ways do we compare those things? But I can tell you, if you're on the buying side, then the way people handle yarn is after you approve them, after you approve fabric, they go as far back as they possibly can without changing the hand. And that's done by adding trash content to yarn. It's very common. I've seen it. You know, how much trash content can you put in an open-end yarn before you know? I know it's 15%. And so that being said, it affects the hand very quickly. You know, when you do something like that, you could actually determine that. So if somebody is sending you fabric and you want to prove it, that there's no negative effect on hand, then you say, okay, well then send me the numbers for this new open-end yarn that you say is softer than the ring spun we've been using. And of course, the blends is more obvious thing, you know, 10% of this, 20, 30, 40, and you can watch how the haptics change, either better or worse. Fabric density, basis weight, these are also very common tricks of the trade. I don't mean this in a bad way. I just mean this is how they survive when they don't get paid enough. You know, people are trying to save another nickel per yard. Fabric density is how it's done sometimes. Basis weight for sure. You know, I've been on the supply side for so long with technologies and additives that, you know, you plan all your business on 190 GSM fabric, and all of a sudden you realize the fabric is now 175, and you lose 15%, you know, of what you were gonna, or 10% of what you were gonna make because of the weight change. Those things will affect hand stiffness, friction, everything. And so those can be measured. Supplier's capability is a nice way to look at just quality. How does hand calculations, how can you use that as a quality assurance? Well, if you're getting the same fabric from different locations and they all say they're the best kind, they're the softest, which I know examples of, then you can just prove it. So it's not, it's a pretty nice capability on the suppliers. The big one, of course, for any of the auxiliary suppliers and dye salespeople is they've always fought the battle of sharing that, you know, use this additive and it will not negatively affect your hand. That's usually the statement we want to hear as buyers. I just don't want it to negatively affect. In this case, you can also sell things that make it softer, like softening package. And if there's anything on this earth that's wasted and nobody cares about, it's softener. I mean, I know people that put so much softener in a continuous pad for cotton that you could walk on it. You know, it's just crazy how much softener they use because it's cheap. But the reality is wastewater treatment now costs money. People care. If you can go from 200 grams per liter of softener to 130 and know that you haven't changed the wash fastness, the softness rating after 20 washes, it's valuable. So, and of course, cost. The last thing that we all compare, which really should be written first, right? Is that how low can I go in cost and still keep my hand? I see a question on the side. Yeah, equipment, of course, sueding, brushing, napping is done for hand, right? This is a whole world there of folks that would value that. So is there anyone here that can think of a category that they would do now that they're sitting here just to teach me before we move to the next slide? What else would we use?
Period underwear.
Underwear?
Period underwear.
Oh, okay. Yeah, I think I'm on the underwear people for sure. Yeah.
It's a little different
I
because
suppose it is. Yeah.
yeah,
Tell us about it.
I mean, put me on mute if you're sensitive about things like this, but like when you're in contact with moisture constantly, if it feels cold, then you feel like it's wet, it's not dry.
That's
so right. If it has I would say less thermal effusivity, so it's not drawing the heat out of you, then you don't feel wet all the time, if that makes sense.
Oh, it does.
Underwear, absolutely, but period underwear or incontinence underwear or even like incontinence pads or period pads, like reusable stuff, that would be great because I don't think a lot is put into research on how it feels when it's wet.
I assume that if the gentleman I work with from MTech was here, he'd tell us that the diaper people use this for that. Now, if not, then a baby cannot tell us if it feels wet, but they advertise that it stays dry, right? The super insert, the insert for Pampers or something that absorbs. That's a great point. You could measure, and you can measure these things dry and wet. So on this instrument anyways. And so that would be great. Norma?
Yeah, that just like Heather's talking about, that would also that's a health issue in senior living and situations like that, where that wetness would contribute to UTIs and other health issues for seniors. So
Yeah, it's actually
wetness.
I'm pretty excited to look into it. So thank you.
Yeah.
Okay, next slide. So we took all this data and I charted it. Now the charting, I love 4-block with 4 square charts. This is the way we should be looking at everything, in my opinion. The question is, what's the X axis and what's the Y? That's the only question. But we should always look at things in something like this, because this separates the story so well for people, especially if you're trying to explain to your boss, what's going on. And they don't, they see financial papers all day, and then all of a sudden there's somebody talking to them about softness of fabric. Putting something up against, I have the y-axis here in smoothness and the x-axis as softness for that list you saw earlier. These are all for the same end use, everything you see here. The most important thing people usually want to know is how far do you have to go in this scale? And you'll notice, by the way, the X scale is different numbers than the Y scale. I believe someday we're going to normalize all these numbers so that they all are in this similar, so they can be shown on a chart better and the vectors can be created. But about a 10% difference is noticeable by the consumer. So if you see something on the right side of this, the other thing is softness is an indirect variable. So not just English cotton count now being indirect, but softness as well. I think I'm voting to turn that around and just change it, while we can. That bigger number is better, but at this time, softness, the number itself, because of the way sound works and the permeability, the bigger the number, the more the sound is bothered, I guess, or maybe it's smoother. I'm not sure exactly. The less soft it is. So if you look at the left side of this chart, you'll see that the small number 4 is the most soft. So the numbers from 9 to 4, there's a 5 difference, and 10% is noticeable. So like every 0.5. In this case, so you would have a very noticeable difference in hand across this grouping. Now, smoothness, and you'll see the words surface softness and surface smoothness. These words are not going to go away. There's a very important distinction between just something that's soft. It's almost as inaccurate as saying I want warm red, right? So for now, we're going to be using those words surface softness and surface smoothness. And what's going to be interesting is I'm going to show now a chart that shows them separated by polyester and nylon and on softness. And then we're going to see how polyester and nylon react to the smoothness number. And that'll be interesting. And I think anyone who's been around polyester, actually, let's guess. Let's do that right now. Who thinks what's the most soft? Polyester, and this is texturized polyester, or nylon 6/6 texturized?
Polyester.
Carla, you know this answer. You're right, it is. So let's go to the next slide. Okay, so I lined them up. Again, the smaller the number, the more soft. Nylons are in the dark blue, polyesters are in the light. The red was just a target fabric that was being compared. And you'll see over on the right side, most of those are polyester. And if you look even deeper, you would see that they're mostly recycled polyester. And I thought that part was pretty interesting. And obviously, we should be doing research on recycled content. And like I said before, whenever you sell additives or yarn, ingredient items to fabric and garments, you're always just trying to say, use my stuff, it will not negatively affect you. And another way of saying it, it'll be price neutral, right? That's the other way we say things. But a recycled polyester in this particular case is not negatively affecting the surface softness, and it's actually the best. So I don't know if there's an actual correlation there, but it certainly comes out versus nylon as being more soft. So go to the next slide. I just normalized the smoothness, which is in orange, on top of the softness ratings, which are those darker bar, the blue, and just to show you that these are not related. It's a very important takeaway from today's meeting that the variables in the parameters of haptics are not really related. Okay, they are independent enough that this company decided to make them independent variables. And so the orange bar is just kind of showing you that it's just not related. They're kind of a random. There could be a relationship here to amount of spandex, maybe. You know, it could be a relationship to density in the fabric, but I didn't have that data. And Tina, I will tell you that you're about to be right about the smoothness rating. So we'll go to the next one. So here we're seeing smoothness. It is a direct correlation, so meaning the bigger the number, the more smooth. And the dark blue is the nylon, and that one came out even more as the smoothest. And to be honest, what I would want to know is what that one on the left is doing, right? That would probably tell you something. That little guy, he missed the party, and there must be some very big difference between that one and all the others. I think there's somebody on the call that might know that, but if otherwise, it's stuff like that that's kind of interesting. It kind of empowers you as a buyer or user of fabric to know what you do. And of course, on the base layer material that's up against your skin, smoothness is an important variable. Right, we'll go to the next. So, of course, you could have checked any of the variables. I'm just throwing up flexibility here. Flexibility is also linear and direct. It is the blue column going up. Most of these things are pretty similar in flexibility. It is not stretch. Okay, so percent elasticity is measured by this instrument, and that is normalized here. It is normally out of 100, so you would measure percent compared to where you were drawn from. It's very similar to words everyone here knows. And so it was divided by 10. If you look at the orange bars, that's the normalized percent recovery. And you'll see some of them are close to 100%, but some of them are not. And not exactly related to the nylon. I have a feeling in polyester, it's more related to the spandex. And if we were to dive into this, you'd probably see that they're all pretty close in spandex quantity. And that's what you'd probably discover. And of course, that's what you would expect from having 18% spandex. And Heather, yeah, the flexibility answers some of the drape questions. People have all sorts of funky drape tests. I used to do one where you pushed it on a tabletop and you measured like how it fell. Was that, Norma, did you used to do that? That was, yeah. So we would just take a fabric on the edge of a table, and you might have had some binder in there or something that would hold it, make it stiff, you know, it would be printed, and you wanted to make sure it's still draped. And you would just see how far you'd go before it started to bend and what angle did it hang. And this is one of those variables here that helps with the drape. And if you add up a couple of the other variables together on the stretch and recovery area and the hystereses, we get that number through this, you can actually solve your drape question. All right, so next. I think that was the data I wanted to show. Yeah. So again, like I started, the color is a big part of the consumer's dollar. Hand is the next, but we've never really truly done this, right? We've never all just stood around talking about newtons or of softness, you know, that kind of thing. I think we should, and I think it's coming. So regardless what anyone does here after this meeting, I believe that in 10 years or less, everyone will spec this, and your mil specs, your tech packs will have these numbers in them. And I think it's just better to know about it now than to wait and catch up like most of us did with the color. I got the experience of introducing spectrophotometers into 3 locations in the first 3 jobs I had. And I can't tell you how much grief I got. It wasn't even my money. I was just some young guy from NC State that came over working in a factory in Western North Carolina. And I was mortified at the resistance to the spectrophotometer. And we used to take the yarn. If it didn't read the color you wanted, you'd blow on it, and then you'd take that yarn and put it outside in what we called the magic bush. It was a fern that we had, and then you bring it inside and read it again. So I think we're going to go through that in our industry here with haptics, but we're a little bit further down the line with things like virtual haptic libraries where people can compare and share and learn how these things relate to real people touching something. Perhaps we're a little bit further down the line for the magic bush treatment. Go ahead, Vijay.
I have the same question for the libraries. You said it's being already used in China and other places, so they haven't created the libraries for this already for their products and all.
Well, MTech has a virtual library, yeah. And the thing is, most of the data that's in there is from the people that use it today. There are hundreds and hundreds of these machines being used every day outside of textiles. And so because of their accuracy and precision concerns with the algorithms for like the total hand difference, they want to focus on apparel businesses, textile businesses, and make sure that it's perfectly accurate and comparable. And so that data pool is a little smaller than the one we have for paper today. But it does exist. And yeah, this is like the $1 million question, Vijay. With all the data, we'd all be all set. But nobody's going to get data if they don't know how to use it. And which is going to come first, right?
So yeah, this is a